Okay. Oh, also, be sure to read the questions carefully. Notice that the proportion of females in a relationship is not the same as the proportion in a relationship that are female. So the proportion in a relationship that are female was 0.762. The proportion of females in a relationship was 0.299. These are not the same. So it's important that you pay very close attention to the wording. And again, I strongly suggest you use this diagramming strategy that I used on these problems here. Okay. All right, let's practice another problem. In a study of handedness in occupations, 10 out of 118 psychiatrists were left-handed, 26 out of 148 architects were left-handed, 5 of 132 orthopedic surgeons were left-handed, and 16 of 105 lawyers were left-handed. Make a two-way table of this relationship. Well, first of all, we need to make sure if it's asking for a two-way table, then that means that we must have two categorical variables. Let's figure out what the two categorical variables are. One of them must be, are you left-handed or right-handed? I was going to call it handedness, but let's just say left-handed or right-handed. And the other variable is occupation. So one of these has to go in our rows and one of these has to go in our columns. Now let's see, we've got 1, 2, 3, 4 categories for occupation. We only have 2 categories for left or right-handed. So since I need more room for the occupations, I'm going to put the occupations in the columns. So let's do this. We've got psychiatrist. Boy, that didn't look right. Psychiatrist, yeah, okay. Architect. Orthopedic surgeons. And then we have lawyers. And then we'll need a column for totals. And then along the rows, we'll just have left-handed, right-handed, and total. And just remember, a two-way table just means 2 categorical variables. That's where the 2 comes into play. Okay, so what do we know here? We know that 10 of 118 psychiatrists, so we've got a total of 118 psychiatrists, 10 of them are left-handed. So that means we must have 108 that are right-handed. And then 26 out of 148 architects are left-handed. So I have 148 architects, 26 are left-handed. So 148 minus 26 will be 122. So we have 122 architects that are right-handed then. 5 out of 132 orthopedic surgeons are left-handed. So we have 132 total orthopedic surgeons. 5 of them are left-handed. So that means we've got 127 that are right-handed. And then we've got 105 total lawyers, and 16 of them are left-handed. So that's going to be 105, 16 are left-handed. So 105 minus 16 is going to be 89. Okay, so now let me take care of finding my row totals. Let's see, 6. 41, 47, 57 here. Well, that does not look pretty, does it? 57 here. Okay, 108, 122, 10, so 230, 357, 63, and 80. Oops, 60. I'm getting 446 here, is that right? I better check it with my calculator. maybe don't trust my mental arithmetic on this one. 108 plus 122 plus 127 plus 89. 446. So now 446 plus 57 is 503. And now I'm actually going to check that all of these column totals add up to 503. So let's check that. 118 plus 148 plus 132 plus 105. 503. So I'm feeling pretty confident that my two-way table is correct. Now let's try to answer a question about a proportion involved in this table. So what proportion of all the people in the sample are left-handed? So remember, all the people in the sample becomes my whole. So that's 503. And then are left-handed becomes my numerator. So because it's for the whole table, then I'm just looking at how many are left-handed out of the whole table. And it's 57. This is a p-hat. And what is this as a decimal? 57 divided by 503 is 0.113. Now we can make a segmented bar chart for this in StatKey. So we will open up StatKey. And now go back to StatKey Home by pressing that button. We have now two categorical variables. So I'm going to select two categorical variables now. And I am going to edit data for this. Let me just double check that the occupation and it's not in there. So I have to edit data. And there is a mistake. Hold on. I've got a little mistake here on this. You do not want to put that row total for handedness there. That's my mistake. So cross that off. But the rest of this data you want to enter exactly as I have it in here in this diagram. Okay, so make sure you're checking out your guided notes. All right, so let's do it. The blank has to stay there. And then I'm putting the categories for the occupation are going to go in this row. So psychiatrists, oh shoot, don't do that. Architects, orthopedic surgeons, and lawyers. Okay. And then I'm going to put the categories. So here I'll put left, the category for the other variables. So categories, left-handed. And then I'm putting all of the values that are in that row, but don't put the totals. So 10, 26, 5, 16. And then I'm going to put right-handed here. And I'm going to put all of those values. So 108, 122, 127, 89. And then I'm just going to delete that third row because I don't have a third row. Okay. And then I'm going to hit OK down here. And you'll see that I get a bar chart, or excuse me, a segmented bar chart for this data set. Now you can check over here to see that I've got my table that matches my table. It does give you an option to switch variables, so you could switch which one's in the rows and which one's in the columns. But I'm going to leave it the way that we just did it. And then you can click here, row, and you can see the row proportions, column proportions, and overall proportions if you'd like. But you'll notice again here in the segmented bar charts, which is what StatKey does for us, is the segmented, not the side-by-side, that we have the ability to display data that has two categorical variables. Again, this is going to be part of your first statistical lab assignment, so please make sure that you are following along and attempting to do these things yourself in StatKey while we're doing them in the lecture video. And you can hit Show Legend here, and it will show you, oh, there's the brown is left-handed and the blue is right-handed. Okay, so let's do one more problem. Let's get back to one more problem that requires us to use a two-way table and answer some questions. So errors in medical prescriptions occur relatively frequently. In a study, 2 groups of doctors had similar error rates, and one group switched to e-prescriptions, while the other continued with handwritten prescriptions. 1 year later, the number of errors was measured. The results are given in this two-way table. So let's do total, and let's find these totals. So we'll just use our calculators to find the totals. So I'm going to do the column total first. This one's going to be 1732. And then 3,594 plus 2,370. That's going to be 5,964. Okay, now I'm going to add the rows. So 254 plus 3,594. That is 3848. And then 1478 plus 2370. That is also 3848. Okay, so if I add those two together, I get 7696. And now I'm going to add these two together and make sure I get the same things. Let me do that real quickly. And I do. If I add these two together, I get that value 7696. So we have taken care of the first question. Fill in the row and column totals. Now, what proportion of all the prescriptions had, there's my verb, errors in them? So remember, this is going to be my whole, this is going to be my numerator. So of all the prescriptions, that's 7,696. How many had errors in them? This is the column for errors. It's 1,732. So from that, I will get 0.225, and that is our p hat. All right, let's try the next one. What proportion of electronic prescriptions had errors in them? So remember, that's my whole. This will be my numerator. So now I'm only looking at electronic prescriptions. So I have 3848 electronic prescriptions. So now I am only in this row, electronic prescriptions. Now how many of those had errors? It's the 254 here. So 254 divided by 3848 is 0.066. That's my p hat for that question. Okay, what proportion of written prescriptions had errors in them? Remember, that's my whole. This will be my numerator. So written prescriptions, now I'm looking at this row. I still had 3848 written prescriptions. And now in that row, how many had errors in them? 1,478. So as a decimal, that's going to be 0.384. And that equals p hat. Okay, what proportion of the prescriptions with errors were written prescriptions? This is my whole. This will be my numerator. So prescriptions with errors, and now I'm in this column. I had 1,732 prescriptions with errors. And now in that column, how many are written? It's 1,478. So 1,478. So as a decimal, that is 0.853. That is a lot. So what we're saying is 85% of the prescriptions that had errors in them were written prescriptions. So seems like there are more errors with written prescriptions than there are with electronic prescriptions. So now let's use StatKey to create a segmented bar chart for this data. So let's do that. And again, make sure, here, let me make a note here so that if you're trying to fast forward or whatever, you would see this note. Make sure you are using stat key along with me in lectures, so you'll know how to do the stat key lab assignments. Okay, so let's create a segmented bar chart for this data. So we're going to go back to stat key. Let's see if there's a chance we have this data in here, this prescription data. And I do not see any prescription data in here, so instead we're going to edit data. We're going to do the same thing we did here, but now I only have error and no errors for my columns. So errors, no errors. And then I've got electronic. And my values here are just 254 and 3594. And then here I have written and 1478 and 2370. Okay, so there's my bar chart. And again, notice that when you look at the bar for errors, how the written errors dominate that particular bar, but that when you look at the bars for no errors, that the electronic prescriptions dominate that particular bar. Now, if we wanted to switch variables, we could also see, hey, for the electronic prescriptions, there are a lot fewer errors than there are for the written prescriptions. So you can switch the variables to change what you are looking at or how you might want to answer some other questions. Okay, so that is it for section 2.1. Make sure that you check your competency on each of these things. Do you know how to display information from a categorical variable in a table or graph? Do you know how to use information about a categorical variable to find proportion with the correct notation? Can you display information about a relationship between two categorical variables in a two-way table? Can you use a two-way table to find proportions? And can you interpret graphs involving two categorical variables?